Hey team, happy Monday. We are here to chat through some of the ideas from our Explain Part 3, working through our astronomy unit. But of course, we always like to start with a little bit of recap and review to make sure our mind is in the right place before we move forward. So, let's think about our nucleosynthesis, what that is again. Hopefully you remember this is our fancy word for fusion, and that's what we're seeing here in our picture. So when elements fuse, we always kind of have two original elements, and they get pulled together due to gravity, and they combine, right? That's essentially what fusion is. And as they combine, we get two outputs of this process of fusion. We've talked about this a few times. It should be a quick recap. Let's go ahead and pause. Go 30 seconds with your team. What are those two outputs of fusion? The more detail you have, the better it is. So pause, chat it out, ready, go. Okay, thinking about what the outputs of fusion are, we can see both here in our picture, right? Our first one is elements that are brand new, right? A new name, and also heavier elements. We can see this one has 4 atomic particles. And then the second one we know is energy. So we're getting an energy output from the process of fusion. So that should be ingrained in your mind at this point, what's happening with nucleosynthesis. And in our part 1 and our part 2, we were introduced to a couple different levels of nucleosynthesis. We had Big Bang nucleosynthesis, so specific characteristics happening in the Big Bang led to fusion or nucleosynthesis of certain elements. Stellar nucleosynthesis, remember, is just a fancy word for stars, right? So nucleosynthesis happening in stars. Massive star or massive stellar nucleosynthesis, bigger stars, and then supernova stars. So here's what I'd love for you to do. Thinking about what each one of those is, talk with your group and figure out which letter, A, B, C, or D, matches up to the description of one of these 4. So you should be able to say Big Bang is A, B, C, or D, stellar, and so on. So take some time, a little bit more than a minute maybe this time. Go ahead and pause, figure out which is which. So Big Bang hopefully reminds you this is the beginning, right? 14 billion years ago, expansion happened, and we really got the building blocks of those elements to start to form, right? We've got our hydrogen, our helium, our lithium. We get an initial combination of protons and neutrons through nucleosynthesis to create the initial elements. So there's our Big Bang. Stellar nucleosynthesis, that is the key to all stars. That's when stars really come to be. So stellar is thinking about hydrogen into helium. And those two forces, gravity and pressure, stay balanced to maintain the star in that original stage. Massive stellar nucleosynthesis, we got 2 choices left. We have either elements more massive than iron or elements up to iron. So when we think about regular massive, that's going to be our elements up to iron. And the star really gets bigger into a super giant stage. Supernova is where we see the star explode, and in the cloud around the remains, we get elements more massive than iron. Again, all of this is happening through nucleosynthesis, that process where elements combine into more massive elements. So thinking about this idea, part 3, you were hearing about spectral analysis. Okay, going back to these fingerprints of stars. You should have a good idea of what those fingerprints are used for, both because we've done this a little already, but also from our reading. So pause one more time, chat with your team, look at your questions from part 3. What are some things that these fingerprints get used for? So thinking about these fingerprints, we know that they're used for element composition. Oh, I forgot to mention, these are our first couple bullet points going in onto our additional information. So you should have on your Notability pulled up part 3, looking at your additional information. I'll give you a second to do that. So you've got your additional information pulled up, and your first bullet point here is this one. Star spectra or fingerprints can be used for multiple things. I really want you to have the blue information down today. Composition, what elements are in the star. We've talked through this one a couple times already. So we should have a good idea of how to use that, right? Matching up the lines, deciding if all the lines are present, then I know that element is in the star. I can also use those spectral lines for temperature to figure out the overall star color, how it rotates, its pressure, and then our new one is really focusing on its motion. Is it moving towards or away us here on Earth, here in the Milky Way galaxy? So this blue is really what we should have recorded in our additional information comments. Now we've talked a little bit about motion relative to Earth in terms of redshift or blue shift, but we haven't totally practiced it yet. What we're looking at is the shift of the star spectra over time. So make sure you get this bullet point in there. A shift in the star spectra over time tells us how the star is moving relative to Earth, towards or away. So here we see on the top a star's original spectra. Remember, spectra is a word for the light being emitted at different energy levels from a star or a galaxy. So we see here this array of light in its original state, and then this down here is the star's spectra in motion. So when I'm looking at this, I'm comparing the top to the bottom, and I'm looking for which way I notice a shift, right? Which way has that spectra shifted over time? Is it shifting towards the red or the blue? And what does that mean? So when I'm comparing my original to the star in motion, I can kind of trace that light down and notice as I look, all these spectras have shifted towards this end. This end, being the blue side, tells me that the star is moving towards me being the Earth, me being the Milky Way galaxy, because its waves are appearing shorter over time, right? Blue is our shorter end of the spectrum. So again, another bullet point here for you to include in your additional information. I'll show you another one. Again, I've got the original star spectrum here at the top. I'm comparing the original to the star in motion. So when I trace these light bars down, the spectra, seeing how it's changed over time, I notice that every single one has a slight shift towards a certain end of the spectra. And that end, in this example, is the red end. So observing this change in spectra over time, I would recognize that this star is going through a red shift, meaning its wavelengths are appearing longer and the star is moving away from us. Again, another bullet point for your additional information. So we talked about this idea of redshift, blue shift, moving towards, away, change in wavelength over time in the previous unit, but we didn't get really a chance to visualize that. Where is this coming from? What does it look like? And how can I assess that myself? And so you're doing that by looking at this change in spectra over time, comparing the original to the current star in motion, and noticing everything is shifting towards one end, either the red, telling me longer waves, or blue, shorter waves, and therefore a motion. The final bullet point today is just a reminder that when we look at galaxies all across the universe, in general, we're pretty much seeing that overall red shift of all galaxies, therefore reminding us that those galaxies are moving away constantly, and the universe is therefore expanding. So this is your final bullet point down in the additional information. Go ahead and pause. Make sure you have all those bullet points in there. Feel free to go back, revisit what those bullet points are, and make sure you have all of them in. Here's the remaining thing to think about then for today. You've got 2 brand new learning targets to crush through. You already should have 1 and 2 done, so nothing to do there. But you've got learning target 3 and 6 now that you should be able to complete. A couple things to help you out with that. I wrote in here a few notes or guiding questions to help you make sure you're answering all parts of the learning target. So you can pause the video at this time and look at these. They're also written on the board in our classroom if you're there today. And you can also find some resources in the unit review folder. So I wanted to show you that. On Schoology, down here in our current unit, there's this unit review folder, which includes videos on learning target 1 and 2 in case you need a recap or help completing those learning targets. Here are 2 new videos, learning target 3 and 6, to help you out. There's a couple videos from last week, Thursday and Friday, going over those notes we talked about in class. And if you'd like to access this particular video, you can get it down here in Explain 3 recap. So all these things are here in the unit review to help you hone in, make sure your learning targets 3 and 4 are ready for today. And looking at our upcoming, which is not updating right now, here's what we're thinking about. Like we said, we have our learning targets to complete, 3 and 6 ready for today. And then also you're jumping into this solar system and stars discussion, which is giving you a couple video resources to look at and a few questions to answer in there. So both 3 and 6 and discussion, plenty of time left in the period to make those happen today. As always, reach out if you have any questions for me, Schoology message, and I'll get back to you as soon as I can. Thanks. See you guys soon.